Hey, and welcome to one of the most important examples you'll see over kinematics. And the reason why this is one of the most important examples is because there are 5 main kinematic equations that we will use almost all year. It is so important you get these 5 kinematic equations memorized. Okay, so important. So in this example, it says an airplane lands on a runway with a velocity of 150 meters per second. How far will the plane travel until it stops if its rate of acceleration is a constant negative 3.0 meters per second squared? Whenever I solve any problems in physics, what I like to do is I like to write out all my knowns and unknowns. So I'm going to do that right now. This is a very useful technique. So I'm going to start with because I'm moving horizontally, I'm going to start with my x's. So my x naught, which is my starting distance, is 0 meters. And 98, maybe even 99.9% of the time, x naught is going to be 0. Almost 100%, like I said, 99.9% of the time, x naught is a 0. My xf is what I'm actually looking for, because it says how far will the plane travel. This is what I'm looking for. This is my question mark. Next, I'll do my velocities. My v naught, my initial velocity, is 150 meters per second. My final velocity, they didn't give me a number, but they did in words. It says how far will the plane travel until it stops. So if the plane stops, that means the final velocity must be 0 meters per second. So always be on the lookout for those phrases if it stops, or if it says something like it starts at rest. If it starts at rest, then that means that the initial velocity is 0. There's a fly in here. There we go. So make sure you watch out for that. Next, my acceleration is negative 3.0 meters per second squared. And the only other variable is time. Now, notice, they didn't give me time, nor did they ask for time. So I don't need that at all. But it is also important to know that sometimes when we do more complex questions, even if they didn't give you time or they didn't ask for time directly, sometimes you have to find time and then go back and do another equation to find the missing variable. But this one's a basic example, so again, it's not one of those right now. So now what I do is I say, what equation has these variables but does not have time? What equation has all the variables I need but no time whatsoever? Well, there's only one equation like that. Vf squared equals v naught squared plus 2a x naught minus xf. Oops, xf minus x naught, my bad. Other way around. Final minus initial. Okay. Next, what I do is if any of these are zeros, I kind of turn them into zeros. Like, for example, I know vf is a 0. So I'm going to make that a 0. And I know x naught is a 0. Like I said, 99.9% of the time, x naught or y naught is going to be a 0. Not always, but a vast majority of the time. Now I can rewrite it like this. 0 equals v naught squared plus 2a xf. Okay, now the goal is to manipulate this equation to get xf by itself, because that's what I'm looking for. To do that, I'm going to subtract both sides by v naught squared. V naught squared. On this side, minus 0 minus v naught squared. 0 minus v naught squared. Okay. That will cancel out the v naught squareds here and here. Next, if I write that, 0 minus v naught squared equals 2a xf. Now, to get xf by itself, I'll divide both sides by 2a. So, whoa. Drop the marker. Notice the 2a's cancel, and here's my final equation. xf equals 0 minus v naught squared over 2a. So now all I have to do is I just have to plug and chug my numbers. So I put 0 minus 150 squared over 2 times negative 3.0. Okay. When I do this, 150 squared, make sure though when you do the 150 squared, it's 0 minus 150 squared. So basically what I'm saying is do 150 squared and make it a negative number, which is negative 22,500. But I like to type all this in at once. That's just how I like to do it. Divided by negative 6. So that's how the negatives kind of cancel. I get, as an answer, I'm going to write it up here, 3,750. But this is not my final answer because how many sig figs are in 150? There's 2. How many sig figs are in negative 3.0? There's 2. This 2 right here, that's 2 times, I'll underline it for you. This 2 right here, that's a constant. Don't worry about sig figs on that one. Okay, it's not 1 sig fig. Don't worry about that. So I got 2 sig figs, 2 sig figs. I'm dividing, so my answer can only have 2 sig figs. So I go 1, 2. Look at the number next to the 7. It's a 5, which tells me to round up. And so my final answer is 3,800 meters. And there you go. So this is your first example of a basic kinematic equation done in 1 dimension. Okay, this is pretty much as easy as it gets. So I like doing these just because, again, there's a lot of equation manipulation. There's all these sorts of variables here or there. There's all these numbers you got to do. Physics is just math and application, and it's just so much fun, and you just feel smart when you get it all figured out. So again, this is the first example. Good luck. I know you guys can do this stuff.